fraud detection of payment transactions. Today, the general mechanisms used for this process are tools like SAS, SIFT, ClearSale. These are established applications and mechanisms that take in an incoming transaction and then tell whether the transaction is a fraudulent or not. The prerequisite for these kind of approaches is that these applications, these third party proprietary tools, generally require a large amount of input parameters to process this kind of request. These parameters may even extend from 50 to 100 or even more, depending on the type of scenario. And the application is required, and we need to provide this by fetching it from multitude of different banking domains. It could be customers, accounts, device history, etc., etc. So even if before we could get started with this application, there is a significant amount of cumbersome upfront work that needs to be put in place. Without that, we cannot even get started. The other aspect to this is that the cost. Every transaction that we send for verification incurs a cost. So, given that our bank is a regional bank or a global bank and has plans of expanding in the future, the volumes of payments is going to increase, and probably it's already very high at this point. So the cost, the accumulated cost that comes in for these kind of fraud check verification also becomes severely prohibitive. Um, the we- in general, it is also required that all the transactions that we have are to be sent to the verification application, and that's where the cost keeps adding. The third aspect here is that these type of tools normally respond in a very rigid way, in the sense that once the result is completed, they will send the result as fraud or not fraud, and they probably will not have enough reasoning or enough explanation behind why and how that decision is reached. The amount of the inputs that we have to send to these tools also have to be in a very specific proprietary format, and this makes our approach quite restrictive. Is there a better way to deal with this situation? As engineers, we always strive to find better, simpler working mechanisms. If you take a close look at this, in reality, of all the total payment transactions that get processed, only a small percentage turn out to be indeed fraud. But in this case, we have to send all the transactions. We are compelled to send all the transactions to this tool, and hence compelled to also pay for those kind that much verification. If we had the way to identify a smaller set of transactions, generally what happens is that a transaction is checked against a general pattern, and if the pattern, if there is a, say, higher larger purchase which is not in line with the smaller purchases that were done recently, or if the location of the purchase is not in the same geographical area of the recent purchases, then that is flagged as a fraudulent transaction. If we could have a reasonably accurate mechanism to determine these smaller set of transactions, then that would help us cut the cost drastically. That's where generative AI can be applied to augment these kind of flows. Just to drive this point, I will show you the target state that we want to be at. So if you see this one, here what we are saying is we are sending a payment transaction which is an unstructured transaction, which says so and so customer has a transaction of so and so amount, and we want our application to process this unstructured transaction and give us reasonably accurate response saying that whether this particular transaction is fraud or not. Now, this is the state we want to be at, what we want. Now, let's talk about how we can accomplish this. For that, we will move to this overall system diagram. In this system diagram, you will see that there are two most important components here. One is our application, which is a standard Java Spring Boot application which uses LangChain 4j, and another component that is our generative AI engine. It uses two parts. One is a VectorDB, which is a which stores information in as semantic embeddings, and the other component is a local LLM server. In this case, we are using Ollama. Ollama server looks utilizes pre-trained foundational models like Llama 2 in order to inference the information provided to it and provide an output based on reason. In the stage one, there are two stages of this flow. In the stage one, what we do is we provide our application a set of a set of transactions which are recent transaction, which are recent genuine transaction of our customer. Let's say Adam Thorpe is one of our customer, and this PDF represents his recent transaction. So these transactions are fed into our flow, and then these are saved as embeddings into the VectorDB. So our application now knows the general spending patterns of our customer, and this process can be extended to all the other customers in the bank. The second stage is all the transactions that are coming live are captured by our application, and these live transactions are then sent to our generative AI engine by using a combination of the embeddings and the local LLM server's reasoning capabilities. Our generative AI application is able to recognize the patterns and also figure out any deviations that may occur, that may be present in the live transaction that is coming in. Based on that, it gives a response to our application back saying whether it is this kind of transaction, this transaction is fraud or not. Let's go into the details of this now. Now we will talk about how the implementation details. Uh, this is our GitHub GitHub location where all the entire code bases you can clone it, and then you can start up this application. This is a Spring Boot Java applications. Um, these are the other components that we talked of. Also, you will see in the training docs there are two PDFs here, which will provide the recent transaction history for our application to our application. Thus, our application will know the spending patterns then. It also uses these other components: Ollama, Elasticsearch, or VectorDB, which we already talked of. The embeddings are created with this particular model, all mini LML L6 V2 embedding model. You could use any other model that works for you. The other important part here is we need a Docker setup. So this link here, which is opened up here, explains how I have set up my Docker. If you wish to, you can follow the same steps. If you wish to, you can follow the same steps as listed here, or you could have your own Docker setup here. Um, The other part is that the machine that I'm running this application on is a standard machine. It has you will at least need this kind of minimum configuration on your machine because this would affect the response time of the application. The more powerful the machine, the better it is for us. So in my case, my RAM is 16 GB. My storage is minimum 50 GB. It is more than that, and I have 4 cores that I have. In the interest of time, what I will do is I will. So these are the PDFs. This is the PDF that represent the recent transactions of two of our customers, John Mayo and Adam Thorpe, and these are fed into the VectorDB. So if we look at the flow, this is how we start off. The very first step is to load the context. What I will do is I've done some of the steps already, and our ultimate goal is to start this application. So I will, for now, I will, because it takes a while. It takes like about a while for this application, this flow to run. I will initiate it right away, and then as we speak, we will come back to the flow. So now we will talk about the components that are implementation component. At the very first stage, we have to load this PDFs into our VectorDB so that our application knows the spending pattern, and our application can learn from the spending pattern. For that, what we do is we have in our Spring Boot Java application, we already have an endpoint that is listed here, and this endpoint needs to be invoked. Before we do that, we have to start our VectorDB. And for that, I have the VectorDB components are already mentioned in there, and this commands for VectorDB are already mentioned, and I have already started this particular component. You see, this VectorDB, which is Elasticsearch, is already running. That's the very first step. The second step is to start your application. This application is the Spring Boot application which you have cloned from the GitHub. There are two steps here. One is to build the application with MVN clean install. We will look at each of those detailed steps, and they're already documented in the Medium article. And the second is to simply start this application with Java minus Java. Okay, so now we will move forward with the flow. In the very first step, we use this particular endpoint, which is there in our application, to load. Now, what it will do is that you see as it starts loading the PDF documents. This one is the PDF document for John Mio. It starts loading it, and it creates these kind of embeddings corresponding to this kind of text. John Mio's recent transaction was for an amount USD 250 in London, United Kingdom on 1st Jan 2024. The item purchase was Ray-Ban eyeglass. Similarly, we have the transactions by Adam Thorpe also extracted from the PDF and then loaded into the VectorDB. The next step that we is, now that we have the context and the spending patterns created into our generative AI application, we will run a live transaction against this application and see how the response is. And this is exactly what we have done some time ago. This is the live transaction, which is an unstructured. This is the exact one. This is an unstructured payment transaction that is passed to this application. When this is passed, there are a few things that happen, and I will explain to you while this processing is continuing here. This is what is happening right now. So our goal is, for this particular transaction, we want our generative AI to autonomously determine if this transaction is a potential fraud. What happens is that when we pass this, invoke this process, at the very first step, our application, our LangChain application, provides a role to creates a role for our generative AI application. In this case, we are telling it that you are an helpful assistant. You will be provided customers' recent genuine payment transaction, that is the PDF. Based on these provided patterns, your task is to classify these transactions as fraud or not. So your role is already clear now. The second part that is done here is these are the recent genuine transactions that are extracted from the VectorDB. Now, because we have in our live payment transaction, we have mentioned Adam Thorpe and his transaction. What LangChain for J and VectorDB semantic search would we do is that it will extract only those embeddings which are most closest to the transaction that we are working on. And this is where the semantic search and comparison actually comes very, very handy. So this is the entire context that gets created that gets created based on the input live transaction that we start with. Also, you will see that we have also instructed our generative AI application to be concise in the response and only state if the test transaction is fraud or not. Also, give a brief reason why for its decision. So this entire thing gets created, and this is then fed into the Ollama inference engine. VectorDB we already talked about. LangChain for J is the tool that we already explained. Retrieval augmented generation. This process that we talked about, which where the input transaction is augmented with additional information and the entire context is created, is called retrieval augmented generation, and Ollama is our server. With the help of this, it is able to figure out the pattern, it is able to compare, and it is also able to reason out why this particular transaction is a fraud or not. And then we will see a response that will come through. Let's see if this is completed or not. It is still going on. All right. So this is the application setup. Let's go through this setup here. We said we need a Docker runtime and a virtualization environment. I'll show you my virtualization environment. I'm using Oracle VM Virtual Box Manager, and my Docker is running here. I'm using a Docker desktop for my Docker related activities. Okay, so once you have this basic setup, you this is what we do. This first thing is we have to start our VectorDB. Our VectorDB, this is the command to start the VectorDB, and in this case we are using Elasticsearch as the VectorDB. In the middle, I'll keep on checking whether this is done or not. Oh, it's done already. Okay, and we will come back to it. This is the VectorDB that we start, and you can check whether it's launched or not based with the standard Docker commands. Docker PS is used here. This is a Spring Boot application, and as I said, first you will need to clone this code base from my GitHub. Second, you will need to build and launch. Build is simply done with mv and clean install, and launch is done with the standard java -jar. This is what follows through. Once the application starts up, it first on the startup connects to the Elasticsearch DB. It loads Llama 2 into the memory. It listens into the incoming live transactions, and also when also it loads the context of the PDFs into the VectorDB. It converts the text, whatever text that we are providing from the PDFs, into embeddings into the VectorDB. It interacts with VectorDB and the Ollama server. This is what is required for it to give the response back. It understands the semantic content, which is the most important step in the entire process, and then it provides a response. This is the overall steps that happens. This is the curl that we used to test our application. This is the one exact curl that we used to test. Now we will see what is the result of n. This is the one that we use for one customer. This is for another. You can try both of this. Here, what does it say? The transaction that we asked for it to test is Adam Thorpe has a transaction on his card showing an amount of USD 7,000 paid for a wristwatch. We want generative AI application to tell us whether this is genuine or a potential fraud. So this is the response of it. Based on the recent genuine transactions provided, the test transaction, this is the transaction text, is most likely fraudulent. So it has determined that it is most likely. Now, let's see what is the reasoning for it. The large discrepancy between the amount paid and any item purchased from Adam Thorpe's usual spending habits suggests that this is not authentic. The large discrepancy between the amount paid and his usual spending patterns indicates that it is not an authentic transaction, and hence it is a fraudulent. This is very reasonable, and such but by having this, by using a generative AI AI's ability to recognize pattern and learn from the pattern, we have successfully accomplished this task of checking whether this transaction is fraudulent or not. You will also notice that generative AI inherently recognized the portions of information from this unstructured text We didn't have to provide it in a specific format, which is required, generally required for our traditional applications. So here it has it picked up the amount and it is compared with the general amounts. It has found that this is a much higher deviation, and also it's picked up that the type of purchase is a watch. So we have successfully accomplished this fraud check here. Now let's look at some other cases. These are other patterns. These are other transactions that I ran earlier, and this one is for John Mayo. Now John Mayo's transaction, we have pending history. We have already fed into our application. Now what we have said is this is a test transaction on John Mayo. John Mayo has a transaction on his card showing an amount of USD 450 made in South Africa. We want our generative AI application to tell whether this is fraud or not. Based on the recent genuine payment transactions provided, the test transaction of for John Mayo's card transaction of USD 450 made in South Africa can be classified as fraud. So it is determined that it is fraud. Now let's look at the reasoning. Is the reasoning sound? The reason is that the transaction location does not match any of the genuine transactions, which all occurred in London, United Kingdom. If you look at the PDF for John Mayo, all these transactions have occurred in the UK, Great Britain area, and none have occurred in South Africa. That's a red flag, and hence it says this transaction is most likely fraud, and that's why this one would be a good candidate for an in-depth analysis into using the other tools. Let's look at the third example. In this case, this is again Adam Thorpe. The transaction is Adam Thorpe has a transaction on his card for an amount USD 2750 paid for taxi fare. So the response, based on the recent genuine transactions provided, the test transaction so and so is as non-fraudulent. So it has determined that it is non-fraudulent. Why so? When the other transaction is fraudulent, why is this not fraudulent? The transaction amount is reasonable and consistent with Adam Thorpe's past spending habits, which include purchase for gym membership, etc., etc. Therefore, there is no evidence to suggest that this transaction is fraudulent. This is also a correct analysis and correct response. You see, one major accomplishment here is we have managed to get responses from for different scenarios. One scenario was geolocation, one scenario was spending patterns, the huge deviation in the purchase cost, and we were able to do it without adding any additional coding. The inherent model and the inherent ability of generative AI to recognize patterns and reason out based on this pattern has helped us in accomplishing this. We have exploited that ability of generative AI to accomplish this task. So we move back to our article now, and these screenshots are basically the same discussion that we had just now. So with that, we come to the conclusion of this article. What have we accomplished? What we have accomplished is that with generative AI, BankNext has been able to drastically shrink the operational cost that are involved in the fraud check process. We are able to send to our tools, the main tools, which are proprietary tools, which charge us only those transactions which are most likely fraudulent, and those will be a smaller set, and hence we will be saving a lot on the cost of it. These other points are related to the actual components and the fine tuning that we have accomplished in this exercise. What are the negatives? Well, the negatives you see are we've already seen. If you look at this, it took a good 5.95, almost 6 minutes for this processing to happen. That means depending on your machine that you're running it on, needs to be really powerful. In my machine, which is a standard machine, it takes this much time, and which may and hence there is latency involved. So there is the computing resources that you need for this kind of processing is high. Typically you need GPUs for this. There also you will recognize. Also, it happens that the responses are not always in the standard deterministic format. In our traditional cases, the responses were always deterministic. It will always follow a format. But here, the content of the response could change with every invocation that you make. And there are also times where the response could be inaccurate or could be deviations from what you expect. Hence, a manual review is absolutely must. as you train these models more and more, as you feed it more and more information, the probability that it will come back with a more consistent response and correct response almost always is very, very high. But again, it all depends on your tuning and general approach that we have followed here for tuning, fine tuning our model is the approach you can use to make your application more and more consistent and more and more reliable. What have we accomplished? Well, what we have accomplished is that generative AI provides an effective mechanism to augment BankConnect's fraud detection operations and massively lower the operational cost while maintaining an acceptable level of accuracy. So with this, we conclude this discussion. Thank you.